everyone, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about in Laplace transforms. I choose Laplace transforms of derivatives and Laplace transforms of integrals. Let us see now. So first I choose L of t, find the value of L of t into cos at. So it is t into another one function. So compare with this original formula t into f of t. Here f of t is cos at. So from this we can write product of two functions here. So we can give the corresponding replacement for this is minus d by ds of L of f of t. What is f of t? Right, take the Laplace for this function. Instead of this, for this t, we can replace by minus d by ds. So suppose if it is d square, we can write minus 1 to the power 2 and d square divided by ds square. So based on this, the general term we can write it as t power n is minus 1 to the power n, d power n and ds power n. So this is a general term we want to use like this. So here for this sum, here we are having only the term t. So I am choose minus d by ds into L of f of t. So based on this, let us see now. So L of t into cos at, which is equal to minus d by ds into L of, what is f of t? This cos at alone. So L of f of t, you can write it as cos at, which is equal to minus d by ds L of cos at. So cos at formula we want to write s divided by s square plus a square. After this, we want to differentiate this function. Numerator as well as in the denominator we are having function this s. So we are proceeding u by v method. So first write this minus and then u divided by v. First we are writing v square, that is s square plus a square the whole square, and immediately write this v. So write s square plus a square and differentiate this u. So differentiating s is 1 minus and write this u 1 s into and differentiate the denominator. Differentiating denominator, s square is 2s. After this, conclude this term minus of s square plus a square minus 2s into s, that is 2s square divided by s square plus a square the whole square. So after this, s square minus 2s square, subtracting these two, we get minus of minus s square plus a square divided by s square plus a square the whole square, and then multiply with this minus and we get s square minus a square divided by s square plus a square the whole square. So this is the answer for this Laplace transform of derivative L of t of cos at, which is equal to s square minus a square divided by s square plus a square the whole square. So we got the result like this. Same thing we can proceed the Laplace transform of integrals. So when we go for this integral means if the function t is in the denominator, here the function t in the numerator we use the differentiation formula, and in the function t in the denominator means we use the integration formula. So the corresponding integration for this t is integral s to infinity, and then we can write this Laplace from L of f of t here, and here this function is with respect to s, because in L of f of t means nothing, it is f of s. So f of s is a function. So function s is, the integration is with respect to s. So we proceed this sum. Based on this, L of sin 3t divided by t, I choose this sum. So the corresponding value we can write it as integral s to infinity L of, here f of t is sin 3t. So here in the numerator f of t and corresponding value is sine 3t. So sine 3t into ds. So integral s to infinity. L of sine 3t value. So what is 3 divided by s square plus a square into ds. So 3 is a constant, take it out. Sorry, instead of a, we are having 3. So 3 into integral s to infinity 1 divided by s square plus a square into ds. Already we know one formula, integral 1 divided by x square plus a square into dx, which is equal to 1 divided by a tan inverse of x by a. So already we know this formula, we can apply now. So instead of a, we are having this 3, that is 3 squared we are having, and then we can apply now 1 divided by a, that is already we are having this 3, write the 3, and then for this integration 1 by 3 into tan inverse of x. Instead of x, here we are having s divided by a value is 3. So s by 3. And with the limit s to infinity. Apply the limit. This 3 we can cancel, and which is equal to, and tan inverse of infinity minus tan inverse of, instead of s you are replacing s only. So again you get s by 3, and tan inverse of infinity value is pi by 2 minus tan inverse of s by 3. And already we know one formula, that is tan inverse of x plus cot inverse of x, which is equal to pi by 2. Okay, so here we got this pi by 2 minus tan inverse, that is here the right side we are having pi by 2, take this tan inverse, that pi by 2 minus tan inverse equal to cot inverse. So we got the answer for this term is cot inverse of x. Instead of x we are having s by 3. So this is the solution for this integration L of sine 3t divided by t. So easily we can replace, if we replace this formula, easily we can get a solution. Thank you.